Now I'm in graphs v4, and what I want to do is design a function that operates on these house graphs. So let's see. The problem is at the end of the file, we want to design a function that consumes a room and a room name and produces true if it is possible to reach a room with the given name starting at the given room. It's kind of an awkward thing to say, but let's look at the examples. If I say, starting at H1, am I able to reach a room named A? Well, that's true because I'm already there. Remember, H1 is the house graph, and in particular, it's the room A. So that's true. If I say starting in graph H1 at the beginning, which is room A, can I get to B? Well, that's true. But if I say starting in H1 at the beginning, which happens to be room A, can I get to C? Well, no, because there actually is no room named C in that graph. In H4, if I start at what we call the beginning of the graph, which was A, can I get to F? That's true. But notice that if I somehow manage to pull out the F room from the H4 graph, which it would take me some work to do, but I could do it, and I say, well, can you get from there to A? The answer would be false, because you can't get from that F to A in that graph. So let's go. This starts out as, and in fact doesn't start out as, it's going to be a regular HCDF problem. We're going to consume a room and a string, and we're going to produce a Boolean. Produce, let's do the stub, that'll make it easier to write this. Reachable, starting at R, Rn. That'll be the stub, and let's call R0 actually. Produce true if it is possible to reach a room named Rn and all. If starting at R0 it is possible to reach a room named Rn. Because I got to give names to those, it made it a little bit easier to write the purpose than the problem statement. So now let's just crank some out. Well, as always, when you get given them for free, you should use them. So let's start with all of these. This is going to be true, and this is going to be true. This is going to be false. And let's do one more case here before we get to this one in H1. Let's, in H1, start at B and see if you can get back to A. We should ask that question. Because the reason starting at the beginning of H1, which is A, you can get to A is because you're already there. So let's say check, expect, reachable question mark of. Now what is it going to be? Well, we're going to start in H1, which happens to be the room A. We're going to get its room exits. That's a list of the exits. It's the list of the room B. We're going to take the first of that. That is now the room B. And we're actually going to start there. So now we're actually starting in the room B. And we're asking the question, can you get to A? And the answer to that better be false. And now we can ask this question. In graph 4, if you start at the beginning, can you get all the way to the room named F? And the answer is you better be able to. We'll run those tests to see if they're well formed. They are well formed, they all fail. So now let's go get the template. Where is that thing of beauty? There it is. We'll put it here. We'll get rid of the stub. We need to rename this to reachable, question mark, and we need to add a parameter Rn. Now Rn doesn't change, what we're looking for doesn't change the whole way through, so we don't have to add that as a parameter of the inner functions. It's a kind of locally defined constant. And the question we're asking is, can you get to a room with this name? Can you get to a room with this name? Well, if you get all the way down here, if the work list is completely empty, then you didn't get there. So false right there. But we need to check that's we didn't get there. How do we know if we did get there? Well, we did get there if string equals question mark room name of R, if the name of the room we're in is the room name we're looking for, then that's true. And we'll wrap the rest of this around the template like that. So we took the original template, which we thought was doing what we wanted to. Remember, we haven't completely tested that template yet. When you construct a complicated template like that, you don't know for sure until you write the first function with it. But I hope it's good. And we basically put a false here to say if we run out of work list, we haven't found what we're looking for. And we put this if here to say if we found what we're looking for, produce true right now. You might not like that doubly nested if, and to be honest with you, I don't love it either. Okay? So what you might want to do is rewrite this like this. Instead of the doubly nested if, do a cond like that. They're both the same. This one looks a bit better. Now let's try it. We've been working on this thing for a while. This is our first real function. Now our tests are either going to come home to us or not. All tests pass. Again, this is a really good example of the power of systematic design. This is actually a slightly complicated function. But notice that using all these higher level design concepts that we've been working with, the type comments, templates, the different ways of producing the template, the fact that this template is a blend of 4 things, filling in these last minute details, having good tests, it got us to the solution for this function pretty quickly. There's a few more functions in this module, and I would encourage you to design the function on your own. Really get yourself comfortable with designing these functions that operate on graphs.